Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of second prep, today we are going to solve questions of Egyptian Knowledge Bank. We have MCQ questions or multiple choice. We are starting with Unit 2, or we have sound pitch today. We will discuss one of the properties of sound. As the last session, we study the wave as we take the mechanical wave or sound wave. Okay, let's start with the first question. Okay, question number one says that two sounds have the same pitch. Which of the following must be the same for sound waves that transmit these sounds? Okay, if we have two sounds the same pitch, what is the meaning of pitch? We said that if any sound waves that have the same pitch means that they are having the same what frequency, as sound pitch directly proportional to what frequency, or we can mention that it is the main strategy or the main function for the sound pitch that we have the same frequency. So the right answer will be letter B. Let's going to okay, question 2 says that we have two nylon strings of equal thickness are different lengths. Each string is held between two balls. Okay, we have here the two strings, they are made from nylon, and the thickness is different in length. Okay, only one is short and the other will be long. The blue one is short and the red one will be longer. Okay, when the strings are plucked, okay, they oscillate. Which string produce a higher pitch tone? Okay, do you think what will be the higher pitch tone? That will be the shorter one. That will be the shorter one. Yes, why? As it will higher pitch, it will be harsh or rough. Higher pitch or higher pitch means that it make shorter string as will be what, as will be soft, not harsh, as some of you said. Okay, no, it will not be harsh, it will be high pitch, maybe it will be soft or smooth. Okay, or higher in pitch and frequency. Okay, so it will be coming from what, coming from the shorter string, that as we see in the activity, if we have high, if we have column of air that shorter, that the sound will be very soft or very thin. Okay, let's going to question 3. Okay, question 3 says that we have an oscillating body or an oscilloscope trace of sound wave is shown. Does the sound wave consist of single frequency or multiple frequencies? Okay, do you think that here we have what, we have a multiple frequencies, we have what, we have a multiple frequencies that make up and down, not making the same wave, not have the same what, not have the same amplitude. Some of them have higher amplitude and we have here one of them have low amplitude, so they are multiple frequencies. So the right answer will be letter B. Okay, let's going to question 4. Okay, question 4 says that we have here oscilloscope. Oscilloscope, it means that uh, like a paper of graph that giving the strating, illustrating the frequencies of different what, of different sounds. Okay, so oscilloscope traces are shown for a complex sound wave and simple sound waves that combine to produce what, to produce complex sound wave. Which color trace is the fundamental frequency of the complex sound wave? We want to know the color trace. We have here purple, green, blue, and orange. We have the first one purple, second one orange, and third one blue, last one will be green. Okay, so what is the color of the line that give the complex, that will be the fundamental of complex? Fundamental means that it is a very simple, and when, or it will be harmonic that coming, or symbol that coming from fundamental. Fundamental consists of from symbol and harmonic that cause what, that cause the fundamental. Okay, so it will be very smooth or very straight line, so it will give smooth or very little in frequency. So we have here the last one, the green. So the right answer will be the green line, that giving what, that giving the fundamental frequency of complex sound wave, means that it will be the simple one, like when you are baby you have a sound, and when you are bigger, that the fundamental will be the base of your sound as when you are growing up. Okay, let's going to question 5. We have here different colors represent the range of frequencies of sound waves that the human ear can detect. Okay, we have here, we said that the human ear can distinguish the sound between what, between 1000 and what, and 20,000. Okay, or 10,000 or 20,000. Okay, we have the purple reaches to 20, reaches to 17, between 10, between 15 and 20. We have the red one starting from 5,000 to 25,000, orange one from 0 to 20,000, and the green from 5,000 to 20,000. The last one, blue, from 0 to 23,000. Okay, do you think what is the frequency of the human ear can distinguish? We have the orange color here, from 0 to 20,000. The human ear can distinguish, or can detect, or can observe the sound wave of frequency from 0 to 20,000 hertz. Okay, here it is the right answer, the line orange from 0 to 20,000 hertz. The below 0 can't be heard, and maximum then 20,000 hertz that can be heard by the human ear, or that we can be detected. Okay, let's going to question 6. Question 6, we have here the diagram between the air particles of two different sound waves. We have the first one with black color, and the second one with dark blue, or dark, or gray. Okay, gray in color. Okay, so we have here the diagram show the air particles in two different sound waves, show where the air is compressed in each wave. The sound wave with the shorter wavelength has greater frequency. Okay, so we have here the shorter in frequency will be what, will be greater frequency, as they are inverse relationship between them. We multiply frequency time wavelength, that giving the velocity or sound velocity. So here we have the two waves, that the first is the black and the second is the gray. So the first question, which color particles make up the sound wave that has the shorter wavelength? Okay, which one will have the shorter wavelengths? Okay, shorter wavelengths means that make a small waves, okay, or small particles that not coming with a very high density or in a high amount. So the gray one will have the what will have the shorter wavelengths. Okay, so the right answer will be the gray. Also, we have the second question: which color particles make up the sound wave of the higher pitch tone? Okay, when we have the shorter wavelengths, that means that we have high frequency. When we have high frequency means frequency is directly proportional to what? To sound pitch. That means that high frequency means high pitch, so it will be the gray also. So the gray wave have short wavelengths and also have high pitch or high sound frequency. So we have here two opposite characters that connecting to each other, that giving the gray wave. Okay, let's going to question 7. Question 7 says that we have an oscilloscope also. We have different colors here, it with the green color, and we have making a compression and refraction. We have a compression here and refraction that low downward. Okay, when sound wave shown long along with the air particles in the sound wave, if the sound wave increased in frequency, okay, which of the following would happen to the peak, means to the graph of the oscilloscope trace? Okay, what do we mean by that? We have high frequency or increased in frequency. Okay, that means that we have make a long wave or will be in the area here below, so it will be in the refraction, so it will be the peak will would be closer together. Okay, so the peaks here will be close together. Okay, so what happened, what which of the following would happen to the peaks of oscilloscope trace? So the peaks would be closer together. It means that the tones are coming, or the air particles are coming closer to each other, so it will make the compression here coming nearer to the line of refraction here, so the peaks would be closer together. Okay, here the peaks will be closer together as what as the wave, or it will be the frequency increases as the frequency will be increases. Okay, let's going to question 8. Question 8 says that an oscilloscope trace of sound wave is shown. Okay, does the sound wave consist of single frequency or multiple frequencies? Okay, we have here the wave come up and down, making the same points above and same points below, so it consists of what? Single frequency only. It consists what? Of single frequency only. Okay, let's going to question 9 says that the diagram shows, we have here diagram shows an oscillating string that is held between two poles. The diagram also shows the air particles above, okay, the string. As the string moves upward and downward, we have here string move upward and downward, that giving the motion of a string here. Okay, when the string moves upward, is the air above the compressed or refract? Okay, when the string move upward means that it make a compression or make a pressure on what? On the air above, so the air will make a compressed or will be compressed, so the right answer will be compressed when the string move upward. Okay, so the right answer will be compressed. Second one, when the string moves downward. Okay, downward means that the area down will be compressed. Okay, is the air above it compressed or rarefied? Okay, so we have the air above, not below. Okay, so the air below will be compressed, but the air above will be what? Will be rarefied. Okay, so the right answer will be letter B, rarefied, or the air particles move away from each other, so they have low density and low speed. Okay, let's go to the last question of our group today. Question 10, we have here two speakers cones. They are the shape, new shape for speakers. We have speakers cones of different size oscillate. Okay, the smaller speaker cone comes from its string is its starting position to the farthest forward position and back again in the same time. Here in the small cone, that it takes a larger speaker cone to move it further forward position, which speaker cone produce a higher pitch one. Okay, when the cone or when the sound coming from the cone come out and return back, so it will take a what it will take a shorter time, that making a sound very hard, or make the sound will be with high pitch. So the right answer will be the smaller speaker cone, the smaller speaker cone that making the higher pitch tone with high frequency, that it will move from a starting position and forward to again in the same time, that greater than what? Greater than the one with high cone. Okay, or big cone. Okay, this is the first point that we have. If we have a small area that the sound can move through it, so the you feel that the sound is magnifying or very high, it means that it has high frequency or high pitch. Okay, I think you understand this. So the smaller speaker cone will cause a high pitch tone or high frequency. Okay, this is the last question of our group today. Thanks for joining. I hope you enjoyed this kind of questions. Okay, we have different multiple questions for Egyptian Knowledge Bank. I hope you can solve all the questions, and I hope you feel easy when we solving them together. Okay, see you soon. I hope you good luck and goodbye.